Hey, in this video we're going to have a look at a bit of an introduction to logarithms. Okay, so we've had a look at our index laws and our index type equations before, our exponential equations. Okay, and we know if a to the power x equals y, okay, that's our exponential equation, then log to the base a of y equals x. Okay, see the notation I use then? Okay, or the language I use, it's log to the base a of y equals x. Okay, and these are linked because exponential functions and logarithmic functions are inverses. Okay, so that's just like our square root function is an inverse with our squared function. Okay, they're opposite operations, they're inverses. Okay, so since a to the power of x is always positive, okay, and we know that from our graph of an exponential, it's always positive. Okay, so that means y is always positive. Okay, so that means that log to the base a of y is only defined for positive values of y. Okay, so for a log function, okay, you can't put in any negative values. Okay, in here, you can't take the log of a negative number. Right, funnily enough, just like we've got index laws, we've got log laws. Okay, and these are very similar, but just you'll see there's a little bit of a tweak to them because they're inverses, so they're not going to be exactly the same. Okay, so here we can see that if we've got log to the base a of m plus log to the base a of n, that's equal to log to the base a of mn. Okay, now you can see this is kind of similar to our index law of a times a to the power n times a to the power m being a to the power m plus n. Okay, so you can see, well, in the past we were multiplying things together and adding our powers. This time we're adding things together and we're multiplying our numbers. Okay, so similarly, when we've got log to the base a of m minus log to the base a of n, okay, that's equal to log to the base a of m on n. Okay, our third law is log to the base a of m to the power of p. So this thing, okay, it's this term here that's to the power of p, not like the log function, just this part here. Okay, what happens is we just bring our p down the front. Okay, so it becomes p log to the base a of m. Now what's really important to remember is often we actually need to go the other way, because notice here, okay, they don't have coefficients in front of these logs. Okay, we can't do this if there's something in front of one of these logs. Okay, that coefficient in front of a log needs to come up as a power. So we can often actually go, oh, I've got this thing in front that I don't like, or that I can't handle, so I need to bring it up here so that then I can keep working with it. Okay, log to the base a of 1 on m, okay, well that can be thought of as log to the base a of m to the power negative 1, and so that power, just like here, comes out the front. So in your textbook, they just kind of skip from here to here, and I don't really explain why. Okay, but it's basically because 1 on m is equal to m to the power negative 1, so then it's just this log law, and the negative comes down the front. Okay, if we've got log to the base a of 1, okay, that's always equal to 0. Okay, so if you've got log of a number equal to 0, it's just, of 1 is equal to 0. Okay, another really important log law, and we're often shooting for this one, is log to the base a of a equals 1. And you'll see in some worked examples why this is an important one. That links really closely with this one here. Okay. Now, we've also got one other thing called our change of base rule. Okay, now it's not always, it's actually in the textbook for 13E, okay, for our logarithms. Okay, but it's a really useful one to know. And that's if you've got log to the base a of m, okay, well, you can change the base. So this was a base a. Okay, we can actually change it, and then we end up with log to the base n of m on log to the base n of a. So you see, n wasn't in here. I picked n. Okay, n could be whatever you like. Okay, and that's why it's useful, because you might have two different logs that you want to work with, but one's got one base, one's got a different base, where you can change one of them into the base of the other one using this, and that will then allow you to do a bit more work with it. Okay, so a really useful one to know. Okay, so we've got some examples of the types of things that we do with logs. Okay, so first of all, we're going to have a look at evaluating a couple here. Okay, so we've got log to the base 2 of 32. Oh, I know what the value is there. Okay, the key thing here is using that rule, there's log to the base 2 of 2, okay, will equal 1. Now, I'm saying 2 because the base is 2. So we want to utilize this. Okay, well you need to look at this 32 and go, well actually at the moment there's 2 there, but 32 is a power of 2. Okay, so 32 is a power of 2. It's to the power of 5. So we can actually write log to the base 2 of 2 to the 5. Okay, and we have that log law that says when this thing's to the power, that power can come down the front. So we can say this is 5 log to the base 2 of 2. And we know log to the base 2 of 2 is 1. So we can say log to the base 2 of 32 is equal to 5. Because we know this is just 1. So we're just left with our 5. Okay, this one's going to be a little bit similar but slightly different. Okay, because we've got log to the base 3 of 1 on 81. Okay, well we need to think about that 1 on 81. Well, that can be written as log to the base 3 of 81 to the negative 1. Okay, well we know that negative can come down the front now. And you guessed it, 81 is a power of 3. So we say negative log 3 to the 3. So log to the base 3 of 3 to the 4. Okay, 3 to the 4 is 81. So that 4 can come down the front now and get multiplied by our negative. So we're negative 4 log to the base 3 of 3. And again, log to the base 3 of 3 is just equal to 1. Okay, so we can say that this is equal to negative 4. Okay. Of course, they get a little bit more complicated, okay, when we're looking at something like this, okay, because here we're just evaluating things, now we've got to use those other log laws. Okay, so the problem we've got here, okay, is that I'm adding them together, but I've got this 2 out the front here. I've also got 2 here that's not going to help me very much either. Okay, so what we need to do is use that log law, okay, use this one, okay, around the other way. So we're going to bring where we had this power before, we brought down the front. Okay, now we're going to take that number out the front, bring it up as a power. So we've got log to the base 10 of 3 squared, which is 9, plus log to the base 10 of 16. Okay, oh, actually, we can go a different way here. There'll actually be even 9. Oh, no, yeah, it'll actually probably be nicer to work with our numbers, actually. Let's go a different way. Okay. I just realised something that's going to make this nicer. 16 is really log to the base 10 of 4 squared. Okay, 2 log to the base 10 of 6 on 5. Okay, this one's actually in the textbook. I think I'm actually going a different way to what they did. Okay, just to show you just a different way of doing it. Okay, this 2 can come out the front. And also to show you the fluid nature of these rules and the fact that there's often more than one way to get to the answer. Right? The thing we see here is these all have a 2 out the front. So you can bring that 2 out the front, factorise it. Okay? Now it's not going to disappear because this isn't equal to anything where we can divide, but we can bring it out and deal with it later. Okay? So then we can say, well, we've got log to the base 10. Now we're adding, so we're going to multiply these together, of 12 minus log to the base 10 of 6 on 5. Okay, well, we're taking away, so that means that we're going to divide log to the base 10 of 12 divided by 6 on 5. Okay, and we can flip and multiply on this. Okay, and go 12 times 5 on 6. And we've got 2 outside of log to the base 10 of, okay, so our 12 and our 6 can cancel down to be 2. We've got 2 log to the base 10 of, hey, 10, look at that. Okay, log to the base 10 of 10, okay, is just 1, so our answer will actually just be that 2 that we brought out earlier. Okay, so it actually all cancels out quite nicely, and we just end up being left with our 2. Okay, so you won't really think of it, but once we took out that 2 as a common factor, way up here, okay, everything else was actually just going to cancel out and leave us with log to the base 10 of 10, which is quite nice. Okay, so the textbook, that's actually worked example 21, and you'll see they do it slightly differently. Okay, so I've got a couple more that we're going to have a look at here. Okay, so for this one, we're actually solving log to the base 5 of x equals 3. Okay, so for this, I have a method that I call the Loopy Method. Okay, I'm sure it's not the technical term whatsoever. Okay, but I call it the Loopy Method because we form a loop. Okay, so when we've got log to the base 5 of x equals 3, then what we're allowed to do is go 5 to the power of 3 equals x. Okay, so we create this loop coming around. That's why I call it the Loopy Method. Okay, we go 5 to the power of 3 equals x. All right, well, 5 to the power of 3 is 125. So that's equal to x. And then you go see that again coming up as well. Okay, this Loopy Method. Okay, so straight away for this one, we've got solve log to the base 5 of 2x plus 1 equals 2. Okay, well, same thing. We can go 5 to the power of 2 equals 2x plus 1. Okay, 5 squared, 25 equals 2x plus 1. Take our 1 away, 24 equals 2x. Divide by our 2, x equals 12. Okay, key here again, that Loopy Method around. Okay, now this question will actually involve the Loopy Method, but we've got a little bit of work to do before we can get to there. Okay, so this one's nice. We're happy there, but this looks like we could do a little bit of work. Okay, so log to the base 3 of x plus 4. Okay, now we can think here that this is log to the base 3 of x take 4 to the power of negative 1. So that power can come down the front, turn this into a positive. So we've got log to the base 3 of x plus 4 plus log to the base 3 of x take 4 equals 2. Okay, well, we can use our log laws now, bring these together, which means we multiply. So we've got log to the base 3 of x plus 4 times x take 4. Okay, and really it should be in a big set of brackets there, just so we know that we're taking log of everything. Okay, if we expand these out, we're going to get log to the base 3 of x times x is x squared, okay, plus x, plus, well, we've got x times negative 4, which will be negative 4x, and then we've got positive 4 times x, which will be plus 4x, then we've got positive 4 times negative 4 is negative 16, okay, equals 2. We can see our negative 4x and then a positive 4x cancel out, so we've got x squared take 16, and that's really because we were a perfect square here. I keep going, now we're up to the Loopy Method. We can say 3 to the 2 equals x squared take 16. Well, 3 squared is 9. Okay, then we look and we go, okay, so let's bring this 16 across. 2 is 25, equals x squared. So x would equal this plus or minus the square root of 25, which equals plus or minus 5. Okay, we need to be a little bit careful here though. Okay, need to be a little bit careful, because if we have a look at this original equation, okay, we've got this term in there, log to the base 3 of x plus 4. Okay, so if I put in positive 5, we're going to get log to the base 3 of 5 plus 4. Okay, that's log to the base 3 of 9, which is going to equal 2. Okay, because that's 3 squared, comes down the front. Okay, so that tick, we like that. That worked out well. Okay, so what happens if we put in negative 5? Log to the base 3 of negative 5 plus 4 gives us log to the base 3 of negative 1. From our log laws earlier, okay, we found that we weren't, well, from our definition earlier, you can see we're not actually allowed to take the log of a negative number. Okay, can't do it, not allowed to. Okay, it's undefined. Okay, so our answer is actually just x equals 5 in this case. So you just need to be a little bit careful there with some of these expressions. Okay, because it's going to cause us problems if we're not careful. Okay, so you just need to be mindful that we can't take the logs of a negative. Okay, look, hopefully that's a good introduction for you for logs, and I'll help you get through 13E.